Welcome to Geometry Chapter 9 review. Tried to start making this movie last night. My slate wasn't working, so I typed some stuff here, and now I have a working slate. So it doesn't matter, but we'll go with what I have here. A figure is translating using the vector 2, -4. What translation would move the vector back to its original image? So since we moved basically 2 to the right, we would want to go back 2 to the left. And since we moved down 4, we want to go back up 4. So to move the vector back to its original image is vector -2, 4. Problem number 2, graph this. So we're going to actually do this. Graph P at 8, 9. Q 5 and R at 5, 7. So that's the original figure. Then graph it after a translation described by the vector -10, 5. So I think I already put these new coordinates down, but basically your P prime is going to go 8 -10 to -2 and 9 plus 2 to 11. So I'm going to be at -2, 9, 10, 11. So I'm going to make some lines there. That's about where P prime is going to be. Q, 8 -10 is -2. 5 plus 2 is 7. So my new coordinates here are -2, 7 for Q prime. And for R prime, from 5 -10 is -5, and 7 plus 2 is 9, so -5, 9. That's R prime. That's my new one. And number 3, the translation vector is vector u of -7, 4. If the image of, find the image of A. So A prime is 6, -4. Basically you want to say, what number did you start at that if you subtracted 7, you got to 6. So if you start at 13, and subtract 7, you get 6. Same thing here. If you're at -4 and you added 4, where were you at before? -8. So the answer is 13, -8. So write the component form for the vector shows the translation of the thin-lined figure to the thick-lined figure. So basically I went through already, and 1, 2, 3, up 2, that's this dot. That's the thin line. That same that corresponding point on the thick line is -4, -4. So to get from 3 to -4, I subtracted 7. To get from 2 to -4, I subtracted 6. So the vector in component form is -7, -6. Also continuing with vectors, person is traveling in a car. You can read the problem, but basically they say 12 miles north. North on a compass, if you think about it, north, south, is an up and down. That would correspond to, on a graph, a y coordinate. So it's actually 12 is our second value in our ordered pair. 6 miles west, west would be to the left, basically, is -6. So basically you were traveling, you got to -6, 12. Then you realized it had gone too far. You went 3 miles south, that's a y value of -3, and 11 miles east. So if I go 6 to the left, and then 11 back to the right, I end up at 5. If I go 12 up and come back down 3, I end up at 9. So the component form of the vector is 5, 9. What are the coordinates of the vertices when the figure is reflected in line N? So W is at -2, -3, X is at 1, 4, and Y is at 4, 0. I'm reflecting in line M, which is X equals 1. That means my X value of 1, 4 is not going to change. At this point in the answers, the only one that doesn't change is here. So that looks like the correct answer. It ends up being the correct answer, but let me go through the other ones. So W is at -2, -3. When I reflect it over the x-axis, not over the x-axis, over x equals 1, the y value doesn't change. So y is still -3. But in this case, from -2 to 1, I'm 3 spaces to the left of 1. If I go 3 spaces to the right of 1, I get to an x value of 4, and as we said, y value doesn't change. Same thing for my y point. My y point is 4, 0. If I'm reflecting over x equals 1, my y value doesn't change, it stays at 0. But I was originally 3, that's 3, that's 1. So I'm actually 2 spaces to the right. If I go 2 spaces to the left, I end up at -1. Sorry, I wasn't at 3, I messed that up. I was at 4. So I'm going to fix that. Made a little mistake there. I'm 3 spaces to the right. So if I'm at 1 and I go 3 spaces to the left, I end up at -2, 0. So my answer is A. And for the next problem, graph of Mn represents the equation y equals 3 fourths x minus 5. So if this is reflected in the x-axis, n is on the x-axis, so it's going to stay there. M is 5 spaces below the x-axis. It's going to go 5 spaces above. 1, 2, 3, 4, 5. And that's going to be my, well, that is a really bad line. I'm going to give you the straight line tool. I'm going to try and give you the straight line tool. There you go. But you can see that where x is equal to 0, which is the y-axis, instead of m being at -5, it's at +5. The answer is D. Graph the triangle whose vertices have the coordinates given below, then draw its reflection in the x-axis. So -7, 2. -2, 2. And -6, 7. They want me to reflect this in the x-axis. I think this is actually just like the problem you had on your quiz. So I'm still going to say at -7, instead of being 2 units above, change the colors here. Instead of being 2 units above, I'm going to be 2 units below. And that's going to be at -7, -2. -2, 2. Instead of being 2 units above, I'm going to be 2 units below. That's at -2, -2. And at -6, 7, I'm still going to be at -6. Instead of being 7 units above the line, I'm going to be 7 units below the line. -6, -7. And that's the new answer. That's the answer, the red figure. Triangle ABC are -3, -1 for A. B is -4, 3. And C is 1, 2. I'm going to use my line tool here because I get a better line. Even though it's purple, I really would have liked red, but that's fine. Now, reflect the triangle in the line y equals x. So you have to remember that when y equals x, you have AB, and you just switch it to BA. Let me change colors here. So my new A, my A prime, is going to be -1, -3. -1, 1, 2, 3. That's my new A prime. My new B prime is going to be 3, -4. Okay, so that would have been -1, 3, 3, 4, and C, instead of being 1, 2, would have been 2, 1. I'm going to get my straight line tool. And that looks a little off, so I want to just check this for a minute. -1, -3. And this would have been, sorry, that's my problem, -1. Wow, Mrs. Falk. So let's do that here. That's what I did wrong here. -1, -3. So that's my A prime. Maybe you caught that mistake at home. So I'm so impressed. Move that line out of the way. Let me move that line out of the way. Let me go to my straight line tool. That looks much better. And I want you to actually be able to do that, to say, wait a second, I think I made a mistake, and go ahead and fix it. That should be over slightly a little bit. That's why that looks off. But B is 3, -4. So maybe that dot will make me feel a little better. Would have been more like right there. And use the graph to complete the sentence. ABCD is the image, ABCD prime is the image of ABC under a rotation. Okay, if I do it that way, that is 90 degrees clockwise. But they don't have that as a choice. What they have as a choice is 270 counterclockwise. And 270 counterclockwise is the same as 90 degrees counterclockwise. So A is the correct answer. The graph below represents that equation. We're going to rotate this counterclockwise. So have to remember our rule for a counterclockwise 270 rotation, B, but it's -A. So point N is at 3, 0. This is my A value. My opposite of my A becomes the Y value of my coordinate. So the answer is D. And if you think about this point here, that's 1 quadrant, that's 2 quadrants, that's 3 quadrants. So the new N is going to be at 0, 3. And this M would be over here. But they only asked us for N. Number 12, graph the figure with those vertices and then rotate the figure 90 degrees counterclockwise. So 5, -2, 1, 2, 3, 4, 5, -2. 7, -4. 4, 1, 2, 3, 4, for -7. Started to go up 7, but it's down 7. And 2, -5. So, of course, straight line tool and connect those. Now, 90 degrees counterclockwise, the rule is AB becomes -BA. So my first point, 5, -2, becomes 2, 5. 2, 1, 2, 3, oh, right there. The next one, negative b, so that becomes 4, 7. 4 be in quadrant 1 because it's a counterclockwise rotation, so everything's going to be positive. Negative b, so that's 7, 4, that's 5, 6, 7, up 1, 2, 3, 4. And the last one, negative b, is 5, 2. 1, 2, 3, 4. Oh, the 5's marked. 2. Straight line tool. I think this looks a little messy. I think it has to do with the fact that I don't have good coordinate lines. Those are the vertices there. And I'm going to double check it. So that would be 2, 5. So that would be 2, 5. 7, 4 would be 4, 7. Oh, that's my problem. So I do want to check these. 5, 6, 7. It would be more like there. That'll look better. I'm going to move those lines away. And once again, let me get my straight line tool. Oh, now it's red. Don't ask me. Okay. Oops, I did not want to do that. Go back. I hope you're having fun watching my errors here. So 7, 4 is about there, and 5, 2. So I fixed the error. That looks a lot better. Okay, so for number 14, we want to find the value of y. The first thing I want you to get is, since we're rotating, this is congruent to this, and this is congruent to this. But if I try to set up 4y equals 2x plus 8, I can't do it because I have two variables. But over here I have 3x is equal to 6. Really, this is a system of linear equation problem. If 3x is equal to 6, what's x equal to? 2. So I'm going to put 2 in for x. 2 times 2 is 4, plus 8 is, so if 4y is equal to 12, what's y equal to? 3, and that's the answer. Does that make sense? There it goes. Okay, so for number 15, which glide reflection could map triangle ABC onto A prime, B prime, C prime? So it's a glide reflection, meaning we're going to translate and then reflect. So hopefully you can see that this is going to be a translation over the y-axis. All right? But first I need to get this scooted down. So I can use any of these points. I'm going to use this point. To get from here to here, I have to first move it down 3. That's y minus 3. So at this point, it could be B or it could be D. Why can it not be A or C? Yeah.
You're moving the x down to the left.
Right, here you'd be moving the x to the left, and that's not what we want to do. Now, the part that's a little tricky is you wanted to say it's a reflection in the y-axis, but they don't have that choice. But anywhere on the y-axis, x is equal to 0, correct? The way to write y-axis as an algebra equation So for this problem, they wanted us to draw a triangle with these vertices. I've already plotted the points, and I'm going to use the straight line tool to connect them. Then they want us to move this figure, x stays the same, y plus 2. So the figure is going to move 2 spaces up. That's my new f, that's my new d, that's my new e. So d prime, e prime, and f prime. I'm going to go through here and grab my straight line tool. Thought it was going to be blue. It's red. And now that I've done that, I need to rotate this 180 degrees, which means each of these, the coordinates are going to change. So my new D was 0, 5. Remember the rule for 180 degree rotation is negative A, negative B. So 0, 5 is going to become 0, negative 5. That's my D double prime. E is 4, 5. That's going to become negative 4, negative 5. And that's the E. And F was at 0, 9. It's now going to be at 0, negative 9. So I'm going to go ahead, use my straight line tool, try and get it in black, see if that works. There we go. And that is my new triangle. We are recording in third period live. This is so exciting. So we need to find the image. It was 17 or 18. It was 17, right? See, already I don't know what I'm talking about. Find the image of ABC after the glide reflection described by the translation. So we're going to translate this figure down to, and then we're going to reflect it in x equals 1. So the first thing I'm going to do is just move everything down 2. So if C was here, C prime is going to be there, correct? If B is here, B prime is going to be here. And if A is here, A prime is going to be here. So now I'm going to use my straight line tool because I just love the straight line tool so much because it makes nice straight lines. And we want to reflect it in the line x equals 1. So to help me out here, I'm going to change the color because that'll be more exciting. X equals 1 is that line there, correct? Okay. So now, A is 2 spaces to the right, correct, of that line. So now I'm going to put the new A, I wanted it to be red, 2 spaces to the left. That's going to be A double prime, correct? Then C, I'll do B prime next. That's 2, 3, 4, 5, 6. That's 8 spaces. Oh, did I count that right? Yeah, 8 spaces to the right. So now 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. So that's B double prime. And C is 1, 2, 3, 4, 5, 6, 7 spaces to the right. So the new one is 1, wait, line am I on here? Right here, right? Right there? No, up, okay. 1, 2, 3, 4, 5, 6, 7. I'm going to get my straight edge tool. I'm obviously not going to get my straight edge tool. I'm going to get my straight edge tool. And in this one, they're not asking for the vertices, are they? If you want to check it, let's figure this out. What are the vertices for A double prime? 18. Each triangle is an image of triangle ABC. Which triangle is the image of ABC after reflection over line T and then a reflection over line R? So you have to assume these lines are parallel. But basically we're talking about A, B, C. When I reflect it, it's going to be at OPQ. And then when I reflect it again, it's at UVW. So the correct answer is UVW. Which of the following letters, if drawn simply, have at least one line of symmetry? It's V. Has a line of symmetry right through the middle. We are recording live in third period. Can the boys closest to the door please stop talking? Yes? No? Well, they're not talking. Okay, so here's the issue. We have talked about rotational symmetry at 180 degrees or less. This is 270. But if I rotate one way 270 degrees, that's the same as rotating the other way, how many degrees? 90. So I need something that basically I can rotate 4 times and they're all the same. 4 being the key because A has 4 things in the middle. So, okay, so I can rotate. If I rotate this little figure here is going to spin around and become where this little figure is here. So it's 90 degrees rotational. It's A. Any questions on that one? Is there a question on this one or a different one? This one. Yeah, what about this one?
If it was like 180 degrees.
If it was 180 degrees, it would be B.
Why not D?
Because look, if I draw a line of symmetry right there, I mean, understand I'm trying to get that in the middle, but then when I rotate this, the 180 degrees, the blank side will be over here.
Okay.
Yes?
If it's 180, couldn't it also be A?
Yes, A has 90 degrees and 180 degree rotational symmetry. Good question. Yes?
So if the question was 90 degrees and you had both choices, which one would you pick?
If the choice was what?
And like
It was 180?
Yeah. Which one?
So for number 21, there are actually some rules that you can apply. We'll get into the rule, but you can do this problem without knowing the rule. And this ends up becoming a bit of a logic problem. So to me, it's actually a great SAT or ACT type question also. Because this is a line of symmetry and it's a hexagon, there's 3 vertices on this side. That means there have to be 3 vertices on the other side. So even if you couldn't come up with the vertices from multiple choice, you can come up with them from a little bit of guess and check. By that I mean, if we look at choice A, 1, 7, okay, would be over here somewhere. The point is, it at least is on the correct line of symmetry. 4, -6, though, is down here. We need 3 points above the line, correct? So at this point, we know it cannot be choice A. Okay? For choice B, we know 1, 7 works. -4, 6 would be over here. It could possibly work, correct? but 5, -1 is down here. It does not possibly work, so it cannot be choice B. Choice C, 1, 7 we've determined works, and -4, 6 we've determined works. -5, 1 also appears to work, so it could be C. Let's just double check D. D is -1, -7. That point is not going to work, so it has to be C. Now, what some of the other students kind of figured out in some of the other suggestions I've had on this one, and it's better to see on your copy, but from here to there's a point of intersection right there. If you try to draw that from here to there is like going through 2 diagonals. If you then went and tried to go through 2 diagonals there, you would come up with a point. Same thing here. One of my students in 4th period, I thought this was like really clever, figured out that I believe from this line to this point. Now I got 4 bells. Why is it not recorded? So I paused for a second. We had a question. Is this a regular hexagon? I do not believe that this is a regular hexagon because it says is the only line of symmetry. And a regular hexagon would have more than one line of symmetry. Okay? So really for you guys at this purpose, if you plot out the possible answers, only one answer makes sense. So it's a little bit more of a logic problem. There are some rules that you could apply if you understand them, but you don't need to understand them to do the problem. Okay, number 22 is the first time that we actually get into a point that may or may not be the origin. They tell us that we're dilating from this, okay? And we don't have problems in geometry honors where we don't dilate on the origin. But basically, if you weren't dilating on the origin, you'd be figuring out how many spaces away from wherever your dilating is, and then basing it off of that. So this is 2 spaces to the right and 1 down. So what is 1/2 of 2? 1. And 1/2 of 1 is, okay, so my new dot in relation to this red dot is here. Here, this vertice is 4 units above the space from which I'm dilating. Half of that is 2. This spot is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 5 to the right and 5 up. 5 divided by 2 is 2.5. So 1, 2.5. 1, 2.5. So my new space is there. My new vertice is there. And this one is 6 spaces to the right of where I'm dilating from. So now I'm 3 spaces to the right of where I'm dilating from. And I can go ahead and connect the lines to draw this new figure. They're not asking for vertices here. I've actually done this without vertices, correct? And that gives you a preview for later on math courses as to how you would actually do a dilation from a point other than 0, 0. Stop. So for number 24, I want you to remember that you want to put the new over the original. C to P prime is the new length, so that's 10. You just want to make sure when you do the original length, it's